Greetings, the Astro 30 here, yet again looking at something I found on the internet which might be a fun little and useful little circuit, and that is one of a temperature controlled fan. That is, you have some form of detection device that will automatically turn a fan on when it's connected to a heatsink, such as in an amplifier or a power supply or whatever you need fan assisted cooling for. So what we're looking at here is a basic circuit. Now you could use an op amp to do the same thing. In this case it's all discrete, just two transistors. Now we're using what is known as a negative temperature coefficient thermistor here, and the other version of that is a positive temperature coefficient, or PTC, and the difference between the two is an NTC will reduce its resistance or relative resistance as the temperature increases, and a PTC will increase its resistance as the temperature increases. So you've got to use the correct type in this circuit, which is a negative temperature coefficient, or it will not work. Now looking at this BC547 transistor here, it's basically being used as a switch, but a voltage controlled switch. And as the voltage or the resistance on this NTC changes, the voltage at the base will increase as this resistance decreases, so it's going to turn the transistor on harder and harder, which will then turn this BD140 transistor on harder and allowing more current to flow through the emitter collector junction to the motor, which is down here. That's where the fan is connected. But we also have some negative feedback coming off of the output of this transistor back into the emitter of this transistor. What this potentiometer does is it controls the point at which the fan starts spinning compared to the temperature of the NTC. That's basically how it works. So you could probably consider this transistor like an amplifier to a point, but one that amplifies DC, not AC. And we've got a 1N4004 flyback diode here on the output, just so, you know, to protect this transistor from any back EMF that the fan motor might produce. And there's a small smoothing capacitor here. So the operation of it is relatively simple. As the temperature here increases, the voltage at this point will also increase, and the speed of the motor will also increase. So it'll actually start off at a slow speed with a little bit of temperature, and as it gets hot, it should rise to the full 12 volt supply rail to the motor, minus the 0.6 of a volt drop here of the transistor, so that the motor will run at full speed when the thing is really, really hot. That's the theory anyway. I haven't actually tested it yet, but we'll get to that. Now this 1/10 over here means that this ratio of this fixed resistor to this thermistor, the fixed resistor has to be 1/10 the value of the thermistor resistance, just so that the circuit operates correctly. If they're the same resistance, then the motor will be running all the time. Well, that's my thought on the circuit anyway. I'll put a link in the description to where I got the original circuit. But what we should do is we should build it up on a bit of breadboard and you know, see how it operates. Okay, so short time later I've got the circuit built up here on the back of the breadboard. Ignore all the other components on the breadboard, that's something else, it's not relevant. All the circuitry's up here. Here's our little NTC, this green thing. That's the 10K one. So what I'm going to do is we're going to just test its operation, and then I want to actually see how low the resistance of this PTC goes with heat. And that's just going into an old fan that I've got mounted in my PCB jig thing, and that came out of an old Technics amplifier that doesn't work, so but the fan does. I've got the multimeter hooked up across where the motor is so we can monitor what the output voltage is at any given temperature. And yes, my desk is a mess, but I've already got my power supply set to 12 volts, and well, we'll just turn the circuit on and immediately nothing happened. The fan's not spinning, and we've got about 0 volts there, 70 millivolts, something like that, at the output, which is not enough to make this fan motor spin. However, I've tested this motor on the power supply, and the minimum voltage you can put through it is 3 volts, and it spins real slow. Any lower than that and then it won't spin. However, it can still stay spinning at 2 odd volts, and if you would stop the motor it would stop, but if you give it a little kick with your finger it would start again. So I'll just touch the NTC with my fingers, and as I'm touching that we can see the voltage is starting to rapidly increase on the output. So currently the potentiometer is about halfway, so if I keep holding the NTC, the motor should, around about 2.5 volts, I'm hoping, start spinning. I'm monitoring the output voltage and it's not increasing higher than 1.9 with my fingers at the moment. So I might adjust this pot a little lower just so that I can get this to start spinning up a lot quicker, because it must be too cold in the room to get the temperature up high enough. Okay, so it's not actually doing much at the moment. I'm going to put that back up to about halfway. That's only because my finger's not hot enough to get the voltage to climb any higher than about 1.9 volts on the multimeter. So what I might do is I might use the tip of the soldering iron. So I'll take my soldering iron and carefully hover it near the PTC without touching it because I don't want to burn it. There we go, fan starts spinning. And we're up to 9 volts, 10 volts, and almost 12. So that's the motor running at full speed now. And as the NTC starts cooling down, the fan starts slowing down. Isn't that cool? Pun intended. And my finger actually is cooling the NTC down and it actually stopped it completely. So yeah, that's basically how the circuit operates and how it should operate. Give it the NTC a little bit of heat and the fan will start. Eventually. Like that. And as things cool down, the fan will slow down. Which is exactly how I described the operation of the circuit on the whiteboard, which is how I envisaged it should work. What I want to know now is, what is the resistance of this NTC when it's actually at its maximum heat, which I reckon is around about the 160 mark or something. So I'll pop him out of the circuit after turning the power off and pop it in some holes elsewhere, and then I'll hook up my multimeter leads across the NTC and I will do a resistance measurement and see what we get. Well, in an ambient state it's closer to 14 kiloohms. So what I'm going to do is I'm going to heat the NTC with the tip of the soldering iron again, and we'll just watch what the resistance on the meter does. And with the tip of the soldering iron close to it, it is dropping in resistance. And it's coming down, coming down. This may take a while, but it is starting to drop its resistance quite rapidly. And that's about where it's going to stop. Yeah, okay. I haven't got a way of getting a direct heat on that. So, not without touching the epoxy dip that's on it with the tip of the soldering iron directly, and that might melt the epoxy, which I don't want to do because it will damage the component. So yes, a simple temperature controlled fan circuit, and it does work. What the relevant temperatures are compared to the soldering iron tip hovering just close to the NTC is, I'm not 100% sure. Probably close to 200 degrees Celsius. So yeah, it works. And I've got not much else to say about this. I mean, you could modify the circuit a little bit, I suppose, but in its current state, I don't think you need to. So anyway, I'm going to leave that one there because, well, that's about as interesting as it gets. So I'm going to leave this video here. If you enjoyed it, please remember to go down below there and like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying see ya. I'll see you in the next one. Thanks for watching.